Hello there. Just found this question to be an interesting one and, of course, an important one. It talks about a horizontal surface on which there is a block of mass 2 kilogram and it's sliding. The speed of the block before it touches the spring is 6 meters per second. And how fast is the block moving at the instant the spring has been compressed? 15 centimeter. Spring constant K is 2 kilonewton per meter. That would be 2000 newtons per meter. So the situation is a block of wood is moving, and I've drawn two diagrams here. The first case here is before the block runs into the spring, and the second case is after the spring has been compressed by 15 centimeters. So it's something like this. The block is here, it's moving, and then the block has run into it. Okay, here the speed is 6 meters per second, but in this case definitely it should be moving much slower. We do not know the speed. That's what you're asked to find. So in the first case, the spring is not compressed, therefore it has no potential energy. The potential energy of the spring is zero. But there is kinetic energy. The block has kinetic energy, and kinetic energy is given by 1/2 times mass times the square of the velocity. Now the mass is 2 kilograms, so it's 1/2 times 2 times the velocity is 6. 6 squared is 36, so you see that the 2 and 2 would get cancelled, of course, there. I could have cancelled those. The 2 and 2 get cancelled and you get 36 joules. Therefore, the total energy of this system, of the block and the spring taken together, the total energy is 0 plus 36, which is of course 36 joules. And the idea is that the total energy would remain constant. So in this case, the spring has been compressed by 15 centimeters, so it has potential energy. Okay, because it's been compressed, as you can see. The potential energy of the spring is 1/2 kx squared, where k is the spring constant, which is 2000 in this case, and x is either the compression or the extension of the spring, which is 0.15 in meters. 15 centimeter is 0.15 meter. When you do that, you get 22.5 joules. Since we know that the total energy must be a constant, we know the total energy taking the potential of the spring and the kinetic of the block, because remember the block is still moving, it has not stopped. So when you take that total energy, you must still end up with 36. Now that you know that the potential energy of the spring is 22.5, this means that the kinetic energy of the block should be the remaining part. That means the kinetic energy is 36 minus 22.5. So we have applied the principle of conservation of energy. 36 minus 22.5, 13.5 joules is the kinetic energy of this block. Therefore, we can set this equal to 1/2 times mass times the square of the velocity, because we know kinetic energy is 1/2 times mv squared. So the mass is 2 kilograms of the block. We're looking for the velocity. Set this equal to 13.5. The 2's will get cancelled. and v squared is 13.5, so v is equal to square root 13.5, which gives 3.67 meter per second. 3.67 meter per second. So the idea in this question was the principle of conservation of mechanical energy. That is, the total energy is constant. Very important problem. Make sure you understand this.